Okay, today we're continuing on with discussing linear functions or linear relationships. Yesterday we talked about one of the characteristics that makes a linear function linear is that it has a constant rate of change, which we call slope. So we're continuing on talking about slope today. So what is slope? Slope, which we often designate with the variable m, is a number that describes both the distance and steepness of a line, right? So two things that work in concert with each other, which makes sense because if we're graphing a line on a coordinate plane, there's both an x and a y coordinate. So those both represent things. The four different types of slope are positive, negative, 0, and undefined. So again, the four different types of slope are positive, negative, 0, and undefined. Okay. So why do we use the name rate of change in slope? Why is that kind of like interchangeable? So when we talk about the rate of change between two things, we're talking about a ratio. So a ratio between the change go down, and the variable y, right, or the coordinate y, over the change in the variable or coordinate x. Okay, so we often refer to this as the rise, meaning how are we moving up and down over the run. Another word for this ratio, of course, is slope. So there's a couple ways that we can calculate slope. So slope, remember we designate that with the variable m. We call that rise over run. And usually that's how we're going to define it when we're looking at a graph. If we're looking at a table or a set of coordinate pairs, we often use the direct slope formula, which is y. Then I'm going to put a subscript. A subscript is below, so I can use control, comma for that. Y2, hit control, comma again to undo that, minus y subscript 1. And this just means the y of a second point minus the y of a first point. So underneath that, we have x subscript 2 minus x subscript 1. And as we should notice, the 2's, they're lined up underneath each other. The 1's underneath each other. We're going to find out later, it really doesn't matter which coordinate point we designate as point 1 or point 2. But what's going to be important is that the y from the point and the x from the point line up above and below each other so that we don't kind of cross points. This would be one coordinate point here, and this would be a second coordinate point here. Okay? So moving on to page 2, let's look at a little bit more about rate of change in slope from a graph. So from a graph, we're going to pick two points that lie on the line and connect the points by making a right triangle with the hypotenuse being the line. And actually, I'm going to be a little bit more specific with the word points. And instead of just points, we're going to call them ordered pairs. And an ordered pair is just another name for a coordinate pair. So we got to pick 2 points or ordered pairs that lie on the line, and then connect the points by making a right triangle with the hypotenuse. And if you know how to make a right triangle, the longest side of the right triangle is called the hypotenuse. And that's going to basically be taken care of by our line. Then we count the rise over the run. So those two things make up our ratio. So what we're going to do next is we're going to practice this. We're going to use the shape tool, which is right here, to make right triangles between the 2 designated points. So I'm going to go up here to my line. I'm going to choose a shape, and I want the right triangle, which is right here. And I'm going to make it so that my right triangle is going to be between these 2 points. Now it looks like I'm going to have to change my right triangle a little bit. So I'm going to want to add a 90-degree angle. So line this up kind of like with your axis. And I'm going to make this blue so I can see it a little bit better. Make it a little thicker, make it a 4-point so I can see that. So I'm going to move it so that it's 1 point's going to be here. I'm going to rotate it so the other point is on the line. Go a little bit closer. So this kind of takes practice. Hold it back. And then I'm going to shorten this. Actually, I'm going to move it so that it lines up. You can see this line is going straight up and this line is going to go straight over. So now you can see that just a little bit better. And actually, I'm going to fill that in so you can really see it. So between these 2 points, I can see that I'm going to have to go up 2. So my rise is going to be 2. And my run from here to here is going to go over. And remember, I'm counting the distance between spots. So 1, 2, and 3. My run here is going to be 3. What we should notice is this is positive slope. So we read from left to right. So when I look at this line, it's going up from left to right. So when it's going up like this, you're running uphill. That's positive. Okay. So if we look at its opposite, negative, you can see we're going downhill. Okay. And I'm going to go ahead and use the shape again to make a right triangle. So shape, I'm going to choose a right triangle. It's going to be a lot easier on this side. Again, I'm just going to make it blue. I'm going to make it solid so I can really see it. And so here, when I'm looking at my rise, I'm going downward. So I'm not moving up, I'm moving down. So I'm moving down 1, 2, 3 blocks. So my rise is going to be a -3. And my run from here is 1, 2, 3, 4, 5. So if you do your slope correctly, meaning you're reading from left to right, and you're either going down or up, your rise will give you the indication of whether or not it's positive or negative. So downhill, negative. And you can see that should not be a -5. This should be a +5. my rise is negative. So a negative divided by a positive is a negative. Then we have zero slope and no slope. The way I like to remember these is with zero slope, you're perfectly capable of walking on flat ground, right? So positive slope, we're going uphill. Negative slope, we're going downhill. Zero slope, we're just walking on flat ground. And then with no slope, it's going, and we can say this no slope, we're actually going to have another name for it. It's going straight up. And the way I remember this is that I can't fly, right? I can't go straight up in the air and fly because I'm not a superhero. That would be totally awesome if I was. So if you look over here, we're not capable of using this as a hypotenuse to draw a right angle using our different crosshairs because we're going straight across. So I can see that my run is 1, 2, 3, 4. So I'm going to have a run of 4. But there is no up, so my rise is 0. And I know that any number any 0 divided by any number is just going to be 0. Whereas on the other side, I can see I have a rise of 1, 2, 3, 4, and my run is 0. And a number cannot be divided by 0. This is considered undefined. Okay? Because when you think about it, if you're doing long division, how many times does 0 go into 4 would be 0. You would never get rid of the inside part of your long division. Whereas how many times does 4 go into 0? 0. 0 times 4 is 0, and you've still eliminated it. So those are the 4 different types of slope. Positive is uphill. Negative is downhill, and I have a negative rise number. Zero slope, I have a 0 on top, and I can walk on flat land. No slope, I can't fly, and therefore I can't divide 4 by 0. So this is undefined in mathematics. So that's kind of the basics of slope and how you would find it from a graph. So next you have to look at your guided practice problems on 25. And there's just 4 questions kind of based off this graph. And there's boxes in there for you to fill out for your answers. And that is how we're going to find slope from a graph.